Okay, so we finished byte, we finished int tester. Let's move on to double. Double is 8 bytes. That's a lot. That's 64 bits. So the max value is a really big number. That's I forgot exactly what it is. It's e to the 308th. So a crap ton of decimals and values. So that's cool. What I wanted to show you about a double is that it's fantastic. It's able to store really, really large or really, really small values. That's really great. But the problem is that the total number of numbers between zero point 0.1 and zero point 0.2 is infinite. And so how can I represent that in a binary situation? The way that doubles work, it's with mantissas and exponents. So if the exponent is negative, now I can represent a decimal, which is fantastic. But representing an infinite number of decimals, I can't do that. So there's a problem with doubles. I can be very, very, very close, but I can't be precise if I'm just adding things. And so there's an issue with doubles that we need to be aware of. As a result of that, just as a tangent, if you work for NASA, you're not going to be working with doubles particularly. You'll be working with an object called big decimal, and that will give you that sense of precision. And those errors that exist in a double with a double variable don't exist with a big decimal object. It's slightly different. Might make sense. Might be more than you need to know. So I'm going to comment out my int tester code. And now I've got my double tester. So again, same thing happens. Main runs, it skips the comments. It says, oh, you want to run double tester. It looks through my code and keeps looking for double tester. Oh, there it is, finds it. And here is the starter code for this. Similar to my int tester, it's outputting the max and the min value of that. I'm creating a double variable called my double. Initializing that to 0. I've got another counter that is also initialized to 0. And what I'm asking you to do is to add 0.1 to my double 10 times. I've got this while true, that's more than 10 times. And so I've got an infinite loop here that is going on. We'll just play around a little bit. We'll just take this system out, and I'm going to put it inside this loop just for kicks, and we'll see what happens. So I'm going to have to stop it with the stop button. But you're noticing that these values, I'm adding 0.1, but I'm getting these really wonky numbers. It shouldn't be this way. And this is the error that I wanted to display and to point out. So we have these rounding errors that are occurring. What I'm asking you to do is to add 0.1, I'm sorry, to my double 10 times. So the condition is not while true. The condition is while count is less than 10. So it starts at 0. I'm going to be adding 1 to count every time through my loop. I'm adding 0.1 to my double. That's enough to get this to work. And what's well, it's less than. It should be okay. Why come you didn't output 10? Because I moved the system out. Thought there should be 10 outputs, but I moved it outside the curly brace. So what happened? I've got these values. So this is the largest and the smallest value of a double. All right, it's 1 point, all 15, I think, different. So the points of precision is enormous, times e to the 308. That's a very, very large number, 300 zeros following that. Or 4.9 times e to the negative 324. Also a very, very small number, and it can be positive or negative. So there's one bit that's taken for sign. So what's happening here is that I ran my double, I added 0.1 to it, I increased count by 1, and that did count 10 times. And I end up with, so I started at 0, it went to 0, went to 0.1, and then 0.2, and then 0.3, and so on. But the end result is 0.9999. I was expecting it to be 1.0. That's what the answer should be. This is not that. It's very, very, very close. All right, but it is not exactly that value. So if I were to round it up, okay, it would be it'd be the right value, but it is not doing that. And so I can have some issues. If after all this, if I added an if statement, if I double equals 1.0, I want it to system out print line success. And if it doesn't, else in all other cases, I want it to system out failure. Failure. Right? Well, the issue is that 0.999999999 is really, really close to 1.0, but it does not, in fact, equal 1.0. So if I were to run this again, it's outputting failure, even though for all intents and purposes, it is. Right? So there are some ways of handling this. What if I just if I rounded it? So my double equal. I'm going to call a math function, another a round function. So it's math.round, and it takes this guy, and it's not a, it's going to be my double. What does that do? Oh, no semicolon. What does that do? And we're waiting. We're waiting. There it is. So it says success. And if I were to put the system out before, I'm sorry, after that round, you'll see that it is 1.0. Round is a cool function, but the problem with it is that it rounds it to the nearest integer. All right, and it will output it as it'll be 1.0. And so it says, yep, that's 1.0. All right, success. So we're good. If I wanted to output, it doesn't equal 0.1. Now I've got to do more mathematical gymnastics to get that to work. So the math.round function will round something, but it rounds it to the nearest integer, to the number to the left of the decimal, not to the right. So you can't round it to, as I said, if I want to see 250.7, right? So I can't round that, get it to that value. So that's the double class. The trick here is that you do have to figure out ways of dealing with. You wanted to know if it is equivalent to 1.0 without that. There's some tricks that you need to do. What is the tolerance that you're looking for? Is that double within that tolerance? It has to be the absolute value of that, because what has been outputting here is less than that, but it's just as likely that it could be 1.000000004 and be darn near close, but it's going to be a little bit more. So the rounding error could go up or it could go down. So there's usually what you see is the double less the tolerance, and then what's the absolute value of that? If it's within that, okay, now I can trust that value. That's fun with doubles. Hope you like it.